Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 16 of the November Daily LeetCode Challenge, and congratulations once again to everyone who have completed the first 15 days in the November Daily LeetCode Challenge. We have just another 15 days to go, and then we'll be done with this November Daily LeetCode Challenge. Today I have a very interesting question here. Okay, this kind of question is the exact level that you can expect in interview because there is so much to explain and so much to understand, and there's so much concept and all in this that you can very conveniently explain all your concepts in multiple ways for the same question itself. Okay, that is, you can demonstrate all the coding that you know within a single question itself. Okay, this is that kind of question. Okay, there are multiple ways to do it. We will also see multiple approaches. At total we'll see three approaches. Okay, I will also include the solution for both Python and Java in this video. Okay, let us quickly go through the question and then we'll start the solution. Okay, it is 3254. Find the power of k size subarrays. Okay, so what is that? This question is very simple, but let us quickly finish it. So if you see here, we are basically given a nums array. It is an integer array, and we are also given an integer k. Finally, we have to return a integer array as the output. Okay. So what you are given? You are given an array of integer nums. Okay. The length is n, and a positive integer k. The power of an array is defined as, so what is the power of an array? Its maximum element if all of its elements are consecutive and sorted in ascending order. Okay, see what this thing means, I will show you with the example. For now you can leave it. Okay, so just remember that, yeah, what they're saying, we have to return the maximum element if the array behaves like this. What is this? We'll understand with example. Fine, we have to return the maximum in case the array behaves like this. That is fine. Next is you have to return -1 otherwise. Okay, so see, if you see here below that, you need to return the power of all subarrays of nums of size k. Okay, yeah, that is fine. So we will see this example now. See, what is the meaning of subarray of size k? Subarray of size k means, if you see here, the first, okay, let me zoom in. Yeah, if you see here basically, so this is the first survey of size k, okay, because k is 3. Then from 2 onwards, this is the second survey of size k, okay. Similarly, this is the third survey of size k, and so on, okay. Then this is going to be the fourth survey, and this is going to be the fifth survey, okay. So each survey we'll have to see whether we have to return this thing, okay. For each survey, we have to return, we have to like follow these two things, okay. Among whichever is followed, we have to return, okay. Either we have to return -1 if this particular thing is not followed, or we have to return +1, okay. That is, yeah, the maximum value in that. So let me quickly explain what is the meaning of this consecutive sorted, okay, consecutive and sorted ascending, okay, order, what they're saying. Okay, so see the example here. So basically what they're trying to say is that, for example, let us say the first element is 1. Okay, the first element is 1. So when they say the consecutive and sorted ascending order, what they means is the second element can only be +1 of the previous element. Okay, that is, the second element has to be 2 here. Okay, if you want to follow the consecutive and sorted order, okay, then ascending order, you will, what is the idea here is, every element should be +1 of its previous element. Okay, so for example, if I have 2 here, the next element has to be 3. Remember, if I have 4 here, this order is not followed. Why? Remember, they are not consecutive. 2 and 4 are not consecutive. 2 and 3 are consecutive. Okay, so 1 and 2 are consecutive, but 1, 2 and 4 are not consecutive because after 2, 3 is not coming, 4 is coming. Okay, so if I write 3 here, they satisfy this property. Okay, so idea is very simple. See, this term looks slightly difficult to understand, but it is very simple. You don't have to do anything here. Okay, whatever is the first element, okay, you have to add +1 to it. Remember, only +1. You cannot add anything like that. Okay, just add +1 to it and get the second element. If you are, let us say this second element is 5, that is, after adding, no, see, you cannot get 5 by adding 1 to the previous element, right, in this case. So it is not following this, as simple as that. Okay, it is not following this. So if you can guess correct, so is this a sorted, that is consecutive and sorted ascending order? Yes, this is one. Okay, so see, try to understand one more thing here. For example, let me write few more elements. So if you see here, every element in this, okay, except the first element, there is 0th element, every element in this is a +1 of its previous element. Okay, do you agree with me? Yes. So let us follow the same here. What is given in the first example, k equal to 3. So what are the subarrays being formed here? Okay, so first subarray is like this, 1 2 3. Okay, so let me quickly write them here so that I can explain you that. Okay, this is the first subarray. So what is the second subarray? Second subarray is going to be this. Okay, remember, we are taking everything of length 3 because k is length 3 given, right? And then this is going to be the third subarray. Okay, we are taking this. I'm writing this also here. Okay, can you quickly tell me now what we have to follow? See, first thing is, because I have taken the way in such a that I've taken this in such a way that this is followed. Okay, consecutive and sorted in ascending order. This is followed. So if, because now this is following that, what I have to return? I have to return the maximum element in this subarray. Okay, one -1 otherwise. Okay, so what is the maximum element in this? Maximum element in this is going to be 3. Okay, so in this the maximum is going to be 3, right? So what is the maximum element in this going to be? It is going to be 4. Okay, so what is the maximum in this going to be? It is going to be 5. So what should be my answer in this case? If this is the example, my answer is going to be 3 comma 4 comma 5. Okay, so this is going to be my answer. So did you notice one pattern here? Remember that whenever, see, one thing is clear, right? Every element has to be a +1 of its previous element. Okay, only +1 is allowed, nothing else is allowed. Okay, one more thing here is, if you see, always the last element is going to be the answer if this property is followed. Okay, if this property is followed, always the last element in that subarray is going to be the max element also. Okay, the last element of the subarray is going to be the max element also. Similarly, the last element of the subarray is going to be the max element also. Okay, if this property is followed. So this is one, help, that is one hint for you to get this answer. Okay, now let us see the example first. Okay, so if you see here, what is happening? See, first three are perfectly, every element here is a plus one of its previous element, so it is followed. So what is the max element here? The last element itself, which is three. Okay, so I'm writing three in here in the answer. Okay, let us go to the next. Okay, two, three, four. In two, three, four, can you quickly tell me whether this follows? Yeah, this also follows. Every element here is a plus one of the previous element. So the last element in this summary is going to be the answer. So four I am writing here. So what is the next? It is three, four, three. No. So three, see, in case of three, four, three, this is not followed. Okay, three and four, it is fine, but after four, five should come, which is not coming. So it is not possible. So we will write -1 for this particular array. Okay, why? Because they are asking us to write -1 otherwise. So we'll write -1 here. Till where we did till this. Okay. Now let us go next. 4, 3, and 2. Okay, nothing is followed. Okay, none of the elements are plus one of the previous element. Okay, it's not at all possible. So again, we are writing -1 here. Okay, 4, 3, 2 also done. What is next? 3, 2, and 5. So again, this is not being followed. Okay, that is every element should be plus one of its previous element is not being followed. So we cannot do that. So we have to write -1 again. So this is the explanation for the first, for example. Okay, in the second example, if you see, again same thing, case 4 here. Take this 4 again. Every element is not a plus, not plus one of its previous element, so again not possible. Every pair you have to write -1. Okay, now come to this, k equal to 2. Okay, first two we take, no, this is not possible. Okay, second two we will take 2 and 3. Okay, yeah, they follow that. Okay, so 2 plus 1 is 3, so this is being followed. So 2 and 3 are following that order. Okay, so we have to write the max of y, that is the last element of this subarray, which is 3. Okay, so write 3 in the answer. Okay, 2 and this is done. Now this again, it is not followed, write -1 in the answer. 2 and 3 again, this is followed, write 3 in the answer. And 3 and 2 again, this is not followed, write -1 in the answer. So I hope you have understood this. Okay, I am assuming that you have understood this. Okay, so let us quickly jump to the solution now. Okay, see, this solution is going to, telling you, this is going to be very, very, interesting, because if this question comes into, I am telling you, at least I will have 1 to 2 hours of, explanation on my code to explain to the interviewer. Okay, so let me quickly run this and show you the output. Yeah, so what I'm doing here, basically, if you see, I'm trying to maintain a DP array. Okay, so you see this code here, what I'm doing, I'm trying to maintain a DP array. Okay, this, I'm first of all recording the length, then I'm maintaining a DP array. Okay, because of this, the space complexity here is rising to O of n. Okay, I will tell you why. See, what I'm doing in this DP array, this DP array is going to be length of the given nums array, and every element is 0 initial. Okay, so what I'm doing is, see, I'm going through every element starting from the first element. Okay, not the 0th element, starting from the index one, I'm going to the last. What I'm doing, I'm checking whether the current element is a plus one of its previous element or not. That's why I'm starting from index 1. Okay, not from index 0, because index 0 doesn't have anything previous to it. Okay, so I'm checking whether the nums of I is equal to plus 1 of its previous element or not. If it is so, what I'm doing, take the dp minus 1 of that and add plus 1 to it. Okay, and store it in dp of I. Very simple. Take the dp of the previous element, add 1 to it, and store it in this. Okay, so what this dp tells me is, see, try to understand this fact. So if you see, this is the dp array output. Okay, this is the dp array output, and this is going to be the your given array. Okay, so what this dp tells me is, see, try to understand this from here. Okay, for 3, the dp value is 2. What it means, say, dp of I means previous to that, how many elements follows this property. Okay, for example, if I am here and the dp value is 2, that means previous to that also 2 of the elements are following this property. As simple as that. Okay, so how to get the answer from this? See, try to understand this fact. What is k is 3 here. Okay, k is 3. Okay, but remember, what is dp value? Dp value tells that, okay, previous to this element, which all elements followed this. Okay, 2. So what I need, see, basically I need, for k equal to 3, what I need a subarray of size 3 to follow this. Okay, that is a subarray of size 3 to follow this. Okay, so can you tell me if my dp value of this particular element is greater than or equal to k minus 1? See, why I'm doing k minus 1? See, remember that dp value of I tells only about the previous elements, it doesn't tell about the current element. Remember that. Okay, so current element just tells that it is greater than this previous element, but dp of I, see, for example, the dp of I of this is going to be 2. Why? It tells that it is, for the previous two element, it follows the same property. Okay, so can you quickly tell me if dp of I is greater than or equal to k minus 1? Why I'm doing k minus 1? Because, see, for 3 the value is 2, right? So I have to do -1, k minus 1, I have to do it. Okay, from that I got this indication. So dp value of any number, if it is greater than k minus 1, can you conclude that it satisfies this property? Yes, it will satisfy this property. As simple as that. Okay, so in that case, what I have to do? In that case, the answer, I have to take the same element. So let us say for this particular element, okay, let us, for this element, dp of I is greater than or equal to k minus 1, which is 2. So the answer for this element is going to be the number itself, that is 3 itself. Okay, do you agree with that? Now come to 4. Okay, for 4, what is the dp value? It is going to be Yeah, for 4. Okay, this is going to be 3. So whether it is greater than k minus 1, obviously it is, greater than equal to k minus 1. What is k minus 1? K minus 1 is 2, it is 3. So it is 1. Okay, so the number, this number itself is going to be the answer. As simple as that. Okay, this number itself is going to be the answer. Fine. Coming to next, now dp value of this. Okay, now dp value of this, whether it is greater than its previous element. No, this is not even greater than its previous element. Okay, so the dp value will remain 0 here. Okay, because none of the elements prior to it are following this. That is, see, if you see the code, no, if you see the code, what I'm doing, see, if this happens, see, by default everything is 0, right? By default everything is, only if it satisfies this property I'm going to add something to it, otherwise I will not add something to it. Okay, as simple as that, right? So if it is 0, that means it is not satisfying this property. Okay, that is the subarray which ends at this. Okay, the subarray which ends at this does not satisfy that property. Which is that property? This property, consecutive and sorting. Okay, so 343 doesn't satisfy this property. So that is dp value of 3 is not greater than equal to k minus 1. So what I have to do in this case, for this particular value, I have to append minus 1 into my answer. So in this case, what I'm doing, I'm appending minus 1 to my answer. Same thing, I see, coming to dp in this, what is dp value of this particular 2? Again, it is 0. Why? Because see here again, this subarray ending at this 2 doesn't satisfy the property, that is consecutive and sorted ascending order is not being followed. So again, I have to append minus 1 to the answer. Okay, now come to this 5. Okay, what is the dp value of this? This dp value of this is 0. What that means? Again, the subarray ending at 5 doesn't satisfy this particular consecutive and sort element property. So what I have to do, again I have to append minus 1. So I hope you understood what I am doing. See, pause this video, take some time to understand what is happening. Okay, you may need to rewind the video, do that, but be very clear what is happening here, because see, we are solving a question, which is, at a harder medium difficult level. Okay, so this is definitely something you should be proud if you are able to understand this part. Okay, this definitely takes some experience, some experience in coding, but yeah, if you are able to understand the first go, you are in the right path. If you're not able to understand, take some time, do some homework, you will get to understand it, but yeah, you have to spend more time. Okay, pause this video, remind, but still keep trying, you will get to understand this. Okay, so if you see the code dp, I'm starting off length n, everything is 0 initially. Here what I'm doing, I'm starting from the first index going till the last index. What I'm doing, if any element is plus 1 of its previous element, what I have to do, I have to just append 1 to the dp value of the last element. Okay, and store it in the current element dp value. Fine, I'm just displaying the dp, then I'm creating answer variable. Then what I'm doing, again, see, remember, my array is starting from this. Okay, the first subarray is going to be this. Okay, that is why if you see here in this particular for loop, basically what I'm doing, I'm starting the I from k minus 1. Okay, why k minus 1? See this example. So see, it is 3, right? What is 3 minus 1? 3 minus 1 is 2. What is second, that is in element of index 2? This is the one. Okay, that is the first subarray is going to end at this particular index. Okay, that is the reason why I am starting here I at k minus 1. Okay, I'm starting the I at k minus 1. Okay, so what you have to do, see, you have to just check whether dp of I is greater than equal to k minus 1 or not. Okay, why it is, why, see, again you will ask me why I'm checking k minus 1. See, because in the way that I have done, if you see here, see, this is the ideal. See, you have to consider this while you are designing the solution. Okay, see, this should satisfy, right? So what is the dp value of 3 in this case? Dp value of 3 is 2. What that means, it means that the previous two elements follow this and the current element also follow this. Okay, so that is why the way I have designed it is coming as 2. So for my solution, I have to take k minus 1. Okay, if it is greater than equal to k minus 1, then probably this is the answer. And what you have to append, we have to append the maximum element in the subarray. I've already explained what is the maximum element of the subarray, the number itself. So if this is the subarray and it satisfies this particular property, consecutive and sorted element, this property, if it satisfies, then the value to be appended is the last element of the subarray. So this I is the that's last index from subarray currently. So I will append nums of I here. Okay, I will append nums of I. If this doesn't satisfy this, what I have to do, I have to append minus 1. As simple as that. Okay, so if you see the time convection and space convection of the solution, see, we are using for loops 2 times. So remember one thing, just to make the solution easier for you, I'm doing 2 for loops. Ultimately, the idea is, even in single for loop, you could have done this part also. You could have done that in Java. Basically, I will be doing that only. Okay, you could have done that, but yeah, just for because in the initial way, I want to show you the very simple solution. Okay, so that it's very easy for you to understand. That's why the dp array formation I'm doing separately, then the actual answer calculation I'm doing separately. Okay, but yeah, these two can be combined. But anyway, in both these arrays, at a max, we will be going off, and that is, we will be going through all the elements. In this case, it is not the case, but still, okay, let us not consider those small things. But yeah, in this, it is going to often. In this also, it is, though it is not full often, but still, we have to take the upper limit, so the time complexity will be O of n. Okay, we are not using anything extra here. It's going to O of n. Then coming to space complexity, we are using a full DP array that is of the size of n, so it is going to be O of n. Okay, and remember one thing, this answer is see, you will say why we are not including this in the complexity. Remember, this answer we are calculating to return. Okay, this is the requirement of the question. My solution did not depend on this. Okay, my solution doesn't depend on this. This I am calculating because I have to return this. Okay, so this will not be included in my time complexity of my solution, so the space complexity of my solution. Okay, because this is not a part of my solution. This is something that I will return to validate my solution. That's why I'm returning, but I don't need this to get this answer, right? So this is what it is, and finally we're returning yeah. So this was the whole solution. Now one thing I want to tell you is that, see here, can you quickly tell me whether I need, see, I'm now going to click, create a link between this solution and the next automatic solution. Okay, so pay attention here. So see, this code I can give in the comment section. So if you're not understood this, pause the video here, try to understand this first. Okay, because we are now going to the next level. So this is the gap now, so try to understand this. So can you quickly tell me whether I need this whole DPI? See what I'm doing here. I just need DP of I is equal to the previous value of DP of I plus 1. Okay, I don't need, see, at any instance I just need the previous elements DP value. Okay, do you agree with me? I don't need the whole array as such. Okay, now if I combine this for loop here itself, I will not need a DP array. Okay, I just need two variables basically. One will be for the storing this value, one will be for storing this value. Okay, I just need two variables. Some will say you can do with a single variable. See, it's up to you, but I want to again make the solution clean. My target is very simple. Instead of having O of n, I want to use a constant space complexity. That is either 2 or 3 or 4 variables, any number of variables you can use, but that should be a constant. It should not depend on n, as simple as that. Okay, currently what I'm using a full array whose length is going to be n. Okay, it is not constant, remember that. So what I need, see, at a step I need only the previous dp value. Okay, for I need that dp value of I minus 1, as simple as that. So can we achieve that? Yes, we can achieve that. We will see in the next solution. Okay, so coming to the next solution, if you see, this space complexity is going to go of 1, that is a constant space complexity. See, I'm using exactly same solution, only two modification is done. First, I'm using two variables. Okay, dp of previous element, dp of current element, exact same solution, only this is the change. Next thing is, I am combining these two for loops. Okay, this for loop and this for loop. Why I need to combine? See here, since I have the dp array, so I can do it separately. Okay, this array can be created separately, but since now I'm going to use variables, so here itself I have to calculate these things also. This part also has to be included within the same array now. Okay, that is the new thing that we have to do. Okay, so I've done the same thing here. See, one more thing difference you will see is that, see, here I'm starting from 1, here I'm starting from k minus 1. Okay, but here I have to start from 0. Why I have to start from 0? I will tell you that also. See, so what is happening, see, this part will be executed. Okay, when there are two cases. Okay, first the k has to be, I has to be greater than 0. Why? Remember, we are doing this comparison, right? What is this comparison? It is checking whether the current element is a plus 1 of its previous element. So when we are at the 0th index, I don't have any previous element. Okay, so that is the reason why I need this condition. Fine. Okay, what I'm doing, see, initially both dp of previous and dp of current is 0. Okay, next what I'm doing here, in this case I'm doing dp of previous plus 1 is equal to dp of current. Okay, otherwise dp of current is equal to 0. See, if you go to this solution, what will see, by default everything is 0. So if this condition is not satisfied, the dp value of that will automatically remain 0. Remember that. Okay, remember that. So here I'm doing the same thing. What I would see, this part is there in this code also. Okay, this part is there in this code also. Okay, in this code also, but here I do not have any else condition. But here I need else condition. Okay, if this doesn't happen, what I have to do, I have to do dp of current is equal to 0, which here I was not doing because every value was 0 by default. Okay, remember that. So I need to do this. Okay, next, now comes this part of the code. From where it is coming, this is coming from this part. Okay, from this part it is coming. Okay, here I has to start from k minus 1, and I am doing this part. Okay, I'm creating the answer. So same thing I have to ensure, if I is greater than equal to k minus 1. Okay, here the I itself is starting from k minus 1, so I don't have to do any if condition, but here I need a if condition to check whether I is greater than k minus 1 or not. Okay, greater than equal to k minus 1. So why I am checking that, remember, I already explained this in the previous video itself. See, what is happening is case 3, right? So the first 7 is going to end at 3, so I have to start processing at 3 onwards. Okay, so what is the index of 3 with reference to k? Can you quickly tell me? K is 3. Can you do k minus 1? What is k minus 1? K minus 1 is 2. So is this index, the index of this is 2, right? So same thing we are doing here. Okay, if I, okay, just a second, yeah, same thing, if I is greater than equal to k minus 1, only then start appending to the answer, as simple as that. Okay, so if only then this will start appending to the answer. Okay, so what we are doing, again same thing, I'm checking if dp of current is greater than equal to k minus 1. See, this thing is here also, dp of current is greater than equal to k minus 1. Okay, same thing I'm writing, dp of current is greater than equal to k minus 1, answer dot append of the current element. Okay, because this array is satisfying this particular property, okay, this property, so the answer is going to be the last element in this subarray. In this subarray, what is the last element? Last one is 3. So same thing I'm doing, nums of 3, nums of I is being appended here. If this doesn't satisfy this property, what I have to append? I need to append minus 1. As simple as that. One very important point which if you forget will not get answer is this part. Okay, at the end of the array, because the current value is going to become a previous value for the next element. Okay, so I have to pass this dp of current is equal to dp of previous, so that in the next iteration what happens, this value, okay, this value becomes the previous element's value. Okay, so you have to do dp of current is equal to this part. Okay, dp of previous is equal to dp of current, and then this print statement is just for your reference to understand what is happening. Let me run this and show you. Yeah, if you see here, this is the same thing. Okay, here I'm just printing and showing you like how it works. If you see, this is exactly same as what we got in the last example. Okay, dp of 0 is 0, dp of 1 is, this tells that dp of 1 is 1. Basically means if you are here, that means that one element previous to this also follows this property. Okay, dp of 2 is 2 means the two elements previous to this also follows this property. Okay, dp of 3 is 3 means when we are here, three elements prior to this also follow this property. dp of 4 is 0 means when we are here. Okay, yeah, when we are here, none of the elements prior to it follow the property. That is, the very next element itself is not following. That means none of the elements follow even before that. That's what it's trying to conclude. Okay, so as simple as that, and so on. Okay, so this is exactly the same. So I will can give you the solution also. You can run and this print statement. That's why I include when I'm giving the solution, so that you can do the tracing part yourself. Okay, you can do this homework yourself. But remember, while submitting, you will have to comment all these print parts. Okay. Now coming to the Java solution finally, because many of you are interested in Java. That's why I've started including Java solution in my videos. Previously, I was not doing that, but yeah, if you're interested, that is a very good thing. You can carry on. This is exactly same as the Python solution that I showed you. Plus, this part is also same. Time and space complexity are also same as Python solution. Okay. Same thing we are doing. We are declaring two variables, dp of the previous value and dp of the current value. Okay, and I'm creating answer which is going to be integer array, because if you see here, the return type is integer array. Okay, so what I'm doing, same thing, I'm starting from I equal to 0 till the last element. Okay, this part is being done. Okay, what it means, if the nums of I is equal to plus 1 of its previous element, okay, do dp of current is equal to dp of previous plus 1, otherwise dp of current will be 0. This part is again what I showed you in the Python solution. This is the same part. Once I becomes greater than equal to this, start calculating the answer. Okay, what I have to do, dp of current if it is greater than k minus 1, what you have to do, you have to append this to the answer. Remember, in Python what we did, we simply appended this to the answer. But in Java, what you have to do, based on the index, see, it is already the space, it is defined, right? The array is already defined. You have to just assign this value to the right index in the array. So what I'm doing, I minus k minus 1, because see, this is the k minus 1, right? So I'm doing I minus k minus 1 to ensure that this particular, the first value should go to the 0th index of the answer. Okay, so that's what I'm trying to ensure. Because I is greater than k minus 1 is condition here, so I'm doing I minus k minus 1, okay, is equal to nums of I, otherwise I minus k minus 1 is equal to minus 1. This condition. Okay, this is exactly same as Python, but only thing is, instead in Python we can append. Okay, in Python when we declare it is empty, and we can keep appending it. But here I'm, because the return type is an integer array. Integer array, when you define, you have to mention the space also. Okay, so since the space is mentioned, what you have to do, you have to assign the right value to the right index. That's what I'm doing. When this part is very very important, remember that without this, the solution will not work. Okay, after the when you come to the end of the for loop, what you have to do, you have to assign the current value to the previous value. Okay, that is the pointer which shows the previous value, you have to assign that the current value, as simple as that, so that in the next loop, this previous value takes the current values, previous loops current value. Okay, as simple as that. Finally, you have to return this answer. Okay, you have to return this integer array as the answer. Let me quickly run this and show you. Yeah, this also gets accepted. Yeah, so you can take that. Okay, let me show you the test cases also that I have included, so that you can also add them. So the third test case that you see here, it's very important one. You can add this if you want. This can help you to segment the solution in the first go itself to get the correct answer. Otherwise, you have to segment multiple times to clear all the test cases. You can take this, and if your solution clears this, probably you will be clearing all the solutions, that is all the test cases in the one go. Okay, so I've explained you two Python solutions and one Java solution, and yeah, that was all for this video. Okay, we have touched the most optimal way to do this. Okay, there is no more optimal way beyond this. Remember that this is the most optimal way to solve this question. Okay, I've explained this. After a long time, we are getting a question where we had a lot to discuss. Okay, there is so many things to discuss in this. Okay, so you can do it any way you want, but yeah, remember, this part is going to be the most optimal thing. The reduction that you can do is maybe I don't think there is any reduction beyond this possible. Okay, I really don't think so. because we are not using any internal function or anything which as such, okay, which is we have to depend on them for the complexity. Okay, we are not doing anything here. Everything we are manually declaring, and we are using it. Okay, we're not using any inbuilt function as such here. So yeah, fine, that was all for this video. This, according to me, was a very nice question. And at last, again, congratulations to everyone who have done till the first 15 days of the November Daily LeetCode Challenge. We have another 15 days to go, and this was the 16th day. That is, we have 14 days to go. So see you tomorrow. If you like my efforts, please subscribe to my channel. It really gives a lot of confidence to continue further, and I hope this is helping you as well. Okay, see you tomorrow. Thanks a lot.